Alright guys, in this video I'm going to show you how to use Tracker to analyze video and generate graphs and lines of best fit for our data. To begin, we're going to go to the Start menu on our computer and we're going to search something called Snipping Tool, S-N-I-P-P-I-N-G. It's a snipping tool. I right click and I hit Pin to Taskbar. This way it's easily accessible. Next, I need to go to my Software Center to download Tracker. So I can search Software Center. It comes up. Click it. Now it loads, and on any Houston ISD campus, I can download Tracker. So I search Tracker. The icon will look like it's purple. Looks something like this up here that you can see. For some reason, Tracker isn't available through my Software Center. So what I did is I go Google Tracker Physics, and it's the first link that pops up, Tracker Physics. And if I have a USB, I can download Tracker to the USB without downloading it to my computer, but I can still run it on my computer. So to do that, I go to Download, I click Download Tracker 4.11 Installer for Windows, and I choose the file location. In this case, this is my external hard drive, and I can download the installer to my external hard drive and save it. I already have it saved. Once the installer is downloaded to my USB, I can click it, click Yes to install, and begin running the setup to download it to the USB. Make sure you always choose your download destination to be the USB. I already have this downloaded, so I'm going to abort the installation process and show you what the Tracker application looks like. So knowing that I saved it here, I can go to Tracker. It's an application, not just the icon. Double click, and my Tracker pops up just fine, and I don't have this saved to my computer. I'm going to go to the hub. I'm going to download this Tracker Prelab, save it to my computer, and then I download this ball toss video, save it to my computer. I've already done that here. Make sure you know where you save these, that way they're easy to find. Now I go back into Tracker, and I'm going to open this video, this ball toss video, into Tracker. To do that, I click Open. I go to copy of balltoss.mov, double click, and it loads. Now for some people, they have trouble pulling this video inside. If that's the case, you probably need to download the VLC Media Player from the Software Center. So you're going to search VLC Media Player from the Software Center. Once I download VLC from the Software Center, I should close Tracker down, re-download the ball toss video, open Tracker back, then search, and that should help me see the video file in Tracker and open it. Now we're going to analyze this video to get some data out of here. So to start with, I click these crosshairs, these purple crosshairs up here, and this brings up my coordinate system. And I want to make sure this coordinate system lies right here in the center of the ball. If this is flipped upside down like this, my graphs are going to be inverted. So you make sure that your angle from the horizontal is 0 degrees. Enter. Now I click this away. Next, I need to set the scale of the video. This video is nice because I have a 62 centimeter line marked right here. So I click this blue line with the number 10. It says Show, Hide, or Create Calibration Tools, and I go to New, Calibration Stick, and down pops this. I need to set this angle from the x-axis to 90 degrees, but I have to do that by dragging. So if I start dragging up along this line and it's negative 30 degrees, I just pull it down the opposite direction. We want to make sure this will be positive. So this is going to be positive 90 degrees. Just line it up. There I go. Okay, this is 62 centimeters, not 100 meters. We're going to set the scale to meters, so I convert 62 centimeters is 0.62 meters. Enter. And I can leave it alone. I've now set a scale of distance for this video. Now I'm going to plot the motion of this ball as it's tossed over into this trash can. To do that, I come back up to this upper menu and click Create, Point Mass. To do this, to start tracking, I need to make sure this is selected. So I want to have click this just to make sure it's selected. And now I come to the video, and while I hold down Shift, I have Shift held down right now, and I click my mouse. I've let go of the Shift now. I hold down Shift again and click my mouse. If for some reason I click on the video and then, oh, it's still going. Okay, so that's good. Click. I'm holding down Shift. When I hold down Shift, you can see this crosshair comes up, or this box. Shift, click. Shift, click. Shift, click. Shift, click. All the way across. We're going to track this whole way. Shift, click. Shift, click. Keep going. Notice how it makes a nice arch. Shift, click. And as I'm doing this, look what's happening over here. I'm getting a graph. I'm generating a graph of my X position versus time. Shift, click. Shift, click. You want to make sure your cursor touches the ball every time. Try to hit the center of the ball each time, all the way down, just until it's about in the trash can. And at this point, I'm done tracking. Now, I need to analyze this graph. So I come over here, I right-click on the graph, and I go down to Analyze. A new window pops up. I need to click Analyze again and make sure my curve fits is on. And now I have a graph generated, and I have a fit name line. AutoFit is always selected, and I can make an equation for this line using the A and B values. I plug these in to my A and B. You're going to need to put this graph into your Motion Prelab. So I'm going to go to my snipping tool. Oops. Click back this. I'm going to go to my snipping tool, and I go New, and I can drag a snapshot of this across. I want to get the fit equation information, the graph, all that good stuff. Now, this automatically copies to my clipboard, so then I can come to my Prelab, which I already downloaded, and I can go Control V. And I've just answered the first question, which says, insert a copy of the X versus T graph in the space below. I did it. What's the equation for this line? All I have to do is type in the A and B values for this equation. So the equation is X equals 1.728 times T plus my B, which is 1.058 e negative 2. And I'm done with the first two questions. Question number 3, what does the slope of this line tell you? Well, this is a slope of position versus time. I'm sorry, this is a graph of position versus time. The slope of a position versus time graph is velocity. Nice. Then number 4, insert a copy of the Y versus T graph in the space below. To do that, I go back to Tracker. And I come to the original Tracker pop-up window, and I can click the label for my y-axis, and I can change it from X position to Y position. And notice how the graph looks like this. If for some reason your graph is upside down, so that would mean that I had my axes inverted. See, if I have it like this, then I just reselect my axes, and I change the angle from the horizontal to 0, and that will set everything right. Now I right click this again, and I go to Analyze, and now I have all these graphs on the screen, 2 graphs, but I want to look at Y versus T, not X versus T anymore. So I go to the X column, I right click it, and I hit Cut Columns, and now I have just my parabola. But the line doesn't match up, and this isn't a line, this is a parabola. So what I do is I change the fit name from line to parabola. I click auto fit, and bam, I now have generated a graph and an equation for this graph. So I go back to my snipping tool, I click new, I drag all the way down, getting all this data, the graph, the fit equation, making sure I have auto fit. It automatically copies to my clipboard. I come back to my pre-lab and I go Control Paste to insert a copy of the y versus t graph in the space below. It wants to know why the y versus t graph is a parabola instead of a line. For this we will say because there is no horizontal acceleration. You may not know what that means yet, but trust me, it's true. We're going to insert a copy of the x, so the v sub x versus t graph in the space below. You'll give me the equation for that line. The slope, sorry, this is the v sub y. Or at least it should be. This should be v sub y. I'll change this. V sub y. Insert a copy of the v sub y in the space below, and what does the slope of the v sub y graph tell you? It gives you acceleration. Yeah, just like that. You'll save this and we'll submit this together in class. So I hope you found this video helpful. If you have any questions, ask your instructor and keep studying. Thanks, guys.